Elements of a representation, items OR and exclusive OR. The common bit languages construct their bits from combinations of simple atomic bits. The usual items in such schemes are the single-minded bits addressed in section 11.2. SP meaning an offer of P, monetary units for the bundle S of items. Formally, the valuation represented by SP is one where V of t equals to B for all t which is the superset equals to S, and V of t equals to 0 for all other t. Intuitively, bits can be combined by simply offering them together. Still informally, there are two possible semantics for an offer of several bits. One considers the bits as totally independent, allowing any subset of them to be fulfilled, and the other considers them to be mutually exclusive and allows only one of them to be fulfilled. The first semantics is called an OR bit, and the second is called, somewhat misleading, exclusive OR bit. Take, for example, the valuations represented by A, B, 3, exclusive OR C, D, 5, and A, B, 3, or C, D, 5. Each of them values the bundle AC at 0 since no atomic bit is satisfied, and values the bundle AB at 3. The difference is in the bundle A, B, C, D, which is valued at 5 by the exclusive OR bit, according to the best atomic bit satisfied, but is valued at 8 by the OR bit. For another example, look at the bit AB3 or AC5. Here, the bundle ABC is valued at 5 since both atomic bits cannot be satisfied together. More formally, both OR and exclusive OR bits are composed of a collection of pairs SI-PI, where each SI is a subset of the items, and PI is the maximum price that he is willing to pay for that subset. For the valuation V equals to S1P1, exclusive OR S2P2, and so on, exclusive OR SKPK, one value of V of S is defined to be the maxima of PI, where the maxima is taken among all those I such that Si is a subset or equals to S. For the value of V equals to S1P1 or S2P2 or and so on, or SKPK, one must be a little careful, and the value of V of S is defined to be the maximum over all possible valid collections, W, of the value of the summations of PI summing for all index I in W, where W is a valid collection of pairs. If for all I not equals to J in W, Si intersect Sj is not empty. Is empty. It is not difficult to see that exclusive OR bits can represent every valuation V. Just exclusive OR the atomic bits S, V of S for all bundles S. On the other hand, OR bits can represent only super additive bits for any two disjoint sets S, T. V of S union T is greater than or equals to V of S plus V of T, since the atoms giving the value V of S are disjoint from those giving the value V of T, and they will be added together for V of S union T. It is not difficult to see that all super additive valuations can indeed be represented by OR bits by ORing the atomic bits S, V of S for all bundles S. We will be more interested in the size of the representation, defined to be simply the number of atomic bits in it. The following basic types of valuations are good examples for the power and the limitations of these two bidding languages. Definition 11.17. A valuation is called additive if V of S is equal to the summations of V of the set J, summing for all index J in S for all S. A valuation is called unit demand if V of S is equal to the maximum of V of the set J, where the maximum is taken among all possible J in S for all S. An additive valuation is directly represented by an OR bid. The set 1 P1 or the set 2 P2 or and so on or the set n PM. While a unit demand valuation is directly represented by an exclusive OR bid. The set 1 P1 exclusive OR, the set 2 P2 exclusive OR and so on exclusive OR the set n PM. Where for each item J, Pj equals to V of the set J. Additive valuations can be represented by exclusive OR bids, but these may take exponential size. Atomic bids for all 2 to the n minus 1 possible bundles will be needed whenever Pj is greater than 0 for all j, since an atomic bid is required for every bundle S, with V of S strictly larger than that of all its strict subsets, which is the case here for all S. On the other hand, non-trivial unit demand valuations are never superadditive and thus cannot be represented at all by OR bids.